Hello everyone, welcome back to my channel. Today let's go over a hard question that I just solved on my own. So I've literally been sitting here for like 3 hours and trying a bunch of times, and then I finally got it. So I'm really happy that I did this without any assistance. So let me show you what I did. And I think the problem is actually kind of confusing, but once you get the brute force down, it's just a matter of optimizing it. So yeah, after a long time, I finally managed to solve it on my own, so let's go over it. So basically, you're given two integer arrays and you want to find triplets, keyword right there. And basically what they're asking for, it's kind of weird, but you'll know that they're asking for, well, let's do a triple loop first. This is what I originally had. Okay, so the triple loop, basically what they're asking for is you have three values, right? And you want to make sure the values, the index of the value in position 2 is actually ascending. So it's kind of weird, but basically here, 0, 1, 3. So 0's index is 0, 1's index is 1, and then 3's index is 0, 1, 2, 3. So that is one valid triplet here. For example, 4, 0, 3 just means that index 4 and 0 is less than 2 is less than 4. So the index where that appears. So let's go ahead and first get all the indices of all the elements inside of the second array. And the end dot append I, or equals to I, because I actually found out that they're all unique, so you don't have duplicate elements, so you don't need a list to store multiple indices because each value only appears in one place in either array. So now you just say if d of nums 1 of I, that index is less than d of nums 1k, the value's index d of nums 1k or nums 1j, then that's a new triplet, right? It took me kind of a while to figure this out, but let's run this. And yeah, it technically passes, but obviously it's going to be way too slow. This is n cubed. So let me show you the way that I came up with to get over time limit exceeded. But basically, first part is understanding the question. Okay, time limit exceeded. So since we want to find triplets, right, we only have to start here because there has to be something on the left and the right side, right? There has to be something on the left and the right side, so we can start from this to this, right? And then what we're going to do is we're going to keep the left and the right side if we're starting here, and then we're going to keep those indices in order so we can do a binary search. So let me show you what I mean. Let's call this left and right. So right is just going to hold the original indices. So for I and in enumerate nums, right dot append. So whatever this value's index is, let's print left nums of I, which is the current value in right. Nums 1. Nums 1 of I. Cool. So the right side is done. Well, right dot remove d of nums 1 of I, because that's the value, right? You want to remove that index. Cool. So we got the right side, and then we also need the left side, which is going to be left, because we're starting here, right? So we can just say dot append nums 1 of 0, which is this value's wherever location it is, which happens to be 0, which is given by this dictionary inside of 2. So let's do left dot append d of nums 1 of I. So cool. Now we have our dictionary or our list. So this is not correct. It seems like we're supposed to remove. Just want to make the picture correct. So let's maybe okay, so that's still not correct. Let's try to get the left side and the right side. so the left is appending. I guess we move this down because it's like the next turn. We just want to make the pictures match. Okay, so cool. We're actually just going to do this because again, we're starting here to here because there has to be a left and a right side and that makes things easier. Okay. And then we can move this up here. Okay, so I guess we still do this. 0 is not. I guess let's use a sorted list because actually we want the indices. So 0. Nums 1 of I, yep. Just to pop 0. So the right side is supposed to have 1 and 3. Why is this still here? Like this? Nope. Okay, I see. If I is bigger than or equal to 1, then we do that because we don't want the first one. Cool. So now we have to just do the left side as well, which left, again, is going to dot append the index in the location of the first value in the index, so it's index 0, in the second array, nums 1 of I, nums 1 of 0. Cool. So now we have what we need. And now what we want to do is, because let's call this current is d nums 1 of I and print current because that's the index. We're comparing indices, right? Because there's no duplicates, so we don't even care about this first position. They're all going to be different, right? Okay, so cool. So now we just have to sort this now. So left is sorted list, left, and then right is going to be sorted list, right. And then also right dot discard d of nums 1 of I. So it's just going to keep it in sorted order because this is not. Let's do that. Left dot add d of nums 1 of I, and then do left here. Okay, let's just double check. So location this is going to be at 2. Location of this, index 1 is supposed to be 1, index 3 is 3. It just happens to be lining up to the values. Here, let's do this example. Okay, so 2. This has an index of 2 here. 4 has an index of 0 here. And then 1, 3, and 4. Because 1, 3, 0, 1, 2, 3. Or this is going to be 3. And then this is going to be 4. Because the indices are in sorted order now from their locations in nums 2. From the values in nums 1. So it gets kind of confusing. But now what we basically just want to do is say how many elements are smaller than current and how many elements are bigger than current, and then just multiply them together because that's how many triplets we can make. Or we can just say for val in left, for v in right, if val is less than current, which is less than right, or v, the indices, right, 0 and 2 and 3, for example, then we have a new answer, right? That's a new triplet, so we can return an answer here. This is what I did as well. I think this is also time limit exceeded. So again, I spent like a good 2 hours sitting here trying to figure out how to optimize this. But then I'm like, okay, why don't we just multiply the lengths of both sides instead of doing this whole hassle? And a little better, but still time limit exceeded. So, okay. So how to get everything smaller than 2 here, and then everything bigger than 2 here, which is the current index. So let's do a binary search, bisect left inside of L. Current B right is bisect right inside of R current. Let's print BL and B right. So let's call this the left side is left up to BL, and then the right side is RB right to the end. Let's print LL, current, and RR just to see if our answer is correct. Okay, cool. So, and again, we have to have a left side, so this doesn't count. If LL and right, then we can print this. Cool. And then here, right, all the numbers here are bigger than current. All the numbers here are smaller than current, and the same here, all smaller, all bigger. So now we just say answer plus equals 2, the length of LL times the length of right, because how many triplets can we make? We can make 2 because this is one, and then this is another one, right? So let's run this and submit it. Okay, this might be time limit exceeded. Because this is the length. Okay, so instead of reconstructing the list, which is n again, we already know that BL is literally how long this is, so let's print BL. Let's print left, and BL just to prove to you. This is literally of length 1. This is literally of length 1. So we can just say BL instead of this. And that helps a little bit. Okay, so if BL is bigger than or equal to 0, so submit this. And this also, same thing, is going to be very slow. So how do we optimize that? Okay, almost there, but let's make some observations again. Let's print B right and right. Okay, so you notice that the length of right, how do we get that? It's minus this. So the length of right, so B right is just, so length is 2 minus BR is 0. Because we already know what the length of right is here, right? Size is length of right, which we're doing here. Why don't we just do, if size is 2 minus 0, so minus 0, right? Let's print size. Cool, so 2 minus 0, 1 minus 0, that gives you, that's how long it is. This is length 2, so let's just do size minus BR. And then this can go, right? And BR is less than length of less than size. And let's submit this. Okay. And there you go, passes all test cases. So again, I'm really happy that I solved this on my own after struggling here for like 3 hours. So again, just pretty proud of that. It's not the most efficient, but again, I'm sure you could do some things here. The SCARD might just be too slow, but either way, it passes all test cases. So yeah, that's it. And thank you for watching and stay tuned for more.